In this video, we are diving into the world of creating a web API, a tool that lets us easily do things like adding, fetching, updating, and deleting data. But hold on, we are not stopping there. We are also cooking up a special library that can fit into any project you have, making it super easy to use our web API. We'll be using a SQL Server database to store our data efficiently. And guess what? We are not just building the API, we are connecting it to a Blazor application. But remember, you can use the library we create with any project you like. If you are curious about Blazor and want to learn more, check out the Blazor tutorial playlist link in the video description. So let's dive in. I have created a new blank solution within Visual Studio. Now we'll proceed to create a new .NET Core Web API project. Let's filter the project types by selecting Web API. Within the options, we can locate the ASP.NET Core Web API project template, which we'll select. The project is being organized within a folder named API. I have assigned the project name as demo.api. You have the flexibility to choose the framework of your preference. I am opting not to enable HTTPS by unchecking the Configure for HTTPS checkbox. Moreover, I am ensuring that the Enable OpenAPI support checkbox remains selected. This enables testing the API using Swagger during the application debugging phase. Let's proceed to create the project now. We'll be utilizing Entity Framework Core to establish a connection with a SQL Server database. To do so, we need to incorporate two essential libraries from NuGet packages. The initial library is Microsoft.EntityFrameworkCore.SQL Server. At the top of the list, you can find the specified library. Let's proceed to install it. Following that, we'll install Microsoft.EntityFrameworkCore.Tools. Now, I'll install this required library as well. With the successful installation of these libraries, we are well equipped to commence our development process. Firstly, let's create a folder named Domain within our project. Inside the Domain folder, I'm creating another folder named Entities. Within this folder, a class named Product is being created. The initial property defined is ID. Rather than utilizing a class, I'm employing a record. In C#, a record is a class or structure that offers specialized syntax and behavior for managing data models. Subsequently, I am introducing a property named product name. Additionally, a product code property is being added. To conclude, an additional property for price is included. Moving forward, I am incorporating attributes that can be utilized by Entity Framework to override default conventions. Firstly, I am adding a table attribute to specify the table name. Subsequently, a key attribute is applied to the ID property, indicating that this is the key property of the entity. Additionally, the database generated attribute is assigned to specify that the database should generate the value. A custom column name is also defined. For the product name property, a custom column name is specified and a max length attribute is assigned to denote the maximum allowed length for this column. Similar attributes are provided for the product code property, with the exception that max length is set to 10. Lastly, for the price property, along with the custom name column name, a specific column data type is indicated. With these steps, we have successfully configured the details for the product entity. Proceeding to the creation of our DBContext class, let's initiate the process by creating a folder named Data within our project. Within this new folder, I'm crafting a class named DemoDBContext. Primarily, this class needs to inherit from DBContext, a component of Entity Framework Core. For the construction of the class, a constructor is created. It should accept DBContext options as a parameter, and this object will be passed to the base class. Considering that the connection string will be retrieved from the appsettings.json file and utilized during dependency injection, it is essential to have this constructor that forwards the DB context options to the base class. Following this, we proceed to create a DB set for the product entity. Subsequently, we initiate the dependency injection process. But before that, let's incorporate a connection string in the app settings.json file. I have denoted it as DB connection and provided the connection string. Moving on to the dependency injection, we utilize the addDBContext method. Here, we specify the DB context class we have created and pass the connection string in the options. Initially, the connection string is fetched from the app settings, and let's make use of useSQL method and pass connection string as the parameter. With the dependency injection concluded, let's proceed to execute the migration script. Here, you can observe SQL Management Studio is connected to my SQL Server instance, displaying that no databases are currently present. I'll now open the Package Manager console to execute the migration script. We'll input the add migration command followed by a name. This action will generate a new migration class with the specified name. Upon execution, you can notice the creation of a new folder named Migrations. In this folder, a class titled DemoDB Migration has been generated. This class contains two methods: the up method, responsible for creating the table, and the down method, which facilitates table removal. Now let's issue the update database command. This command executes the migration file produced by the add migration command and applies the changes. The process has been successfully completed. Let's verify in SQL Management Studio. As you can see, a new database has been created, and within it, we find a table named Product. Now let's examine the table design. Here, the data types precisely match those defined in the attributes. Currently, the table remains empty. Let's move on to creating a controller for performing CRUD operations: create, read, update, and delete. Initially, we select an empty API controller and name it Product Controller. We can remove the auto-generated controller and class as they are unnecessary. In our Product Controller, we retrieve the injected DemoDB context dependency from the constructor and assign it to a read-only object. I am streamlining the constructor by using expression-bodied function. This approach consolidates all components into a single concise line. Subsequently, we create an HTTP GET method to retrieve all products from the database. We can simply return DemoDBContext.products to obtain all products. Next, we create another HTTP GET method to fetch a product by its unique ID. We can filter the products using the received ID value and return it. We make this method asynchronous using single or default async. Following that, we create an HTTP POST method to create a new product, accepting a product object as a parameter. We can add the new product to the table and utilize save changes async to apply the changes. The method returns a created action result with an HTTP status code of 201 and information on how to fetch the newly created product. The getById method also requires an ID, and we can provide it as the second parameter. Also, we can pass the current product object as the third parameter. We'll demonstrate how this method works during testing. Next, we implement an HTTP put method to update an existing product. We utilize the update method and subsequently save the changes. This method returns an OK response. To complete our CRUD operations, let's finalize the implementation of the HTTP delete method to delete a product. This method accepts an ID to identify the product for deletion. Initially, we retrieve the product details using our existing getById method. The result is of type ActionResultOfProduct. Now, we check whether the product is null using the ActionResult.value property, which is of type product. If it is null, we return a not found response. Otherwise, we remove the product from the table. After saving the changes, we return an OK response indicating the successful deletion of the product. Having completed the implementation of all the methods, let's proceed to test the API application. As displayed, the Swagger page is loaded, listing all our implemented methods. Let's systematically test each method to ensure their functionality. Let's begin by testing the get method to list our products. Since we don't have any products yet, the expected result should be an empty list. As anticipated, the method has returned an empty array, confirming its correct functionality. Let's proceed to test the creation of a product. I'll provide the values for the product name, product code, and price, and then execute the operation. As observed, we received an HTTP status code of 201. The response body contains the details of the newly created product. Additionally, in the response header, there is a value named location, representing the API URL to call our getById method. This aligns with the explanation I provided earlier regarding the created@action result. To further validate, let's check the data from SQL Management Studio. You can see that the product has been successfully added to our table. I'll now add another product. Once again, we obtain the details in the response body, confirming the successful addition of the second product. Let's try our get method again. As we have added two products, the expected outcome is to list both of them. As observed, the method has successfully returned both the products, confirming the correct functionality of our get method. Next, let's test the getById method. I'll fetch the product with the ID 2. As expected, the response body contains the details of the specified product. Now let's attempt to fetch the product with ID 1. As seen in the result, we receive the expected details, confirming that the getById method is working correctly. Now, let's test the edit method. I'll edit the product with ID 2, providing a different name, code, and price. As observed, we receive a 200 status code. To confirm the changes, let's check the details in SQL Management Studio. Indeed, the product details have been successfully updated, validating the correct functionality of our edit method. Finally, let's test the delete method. I'll delete the product with ID 1. As expected, we receive a 200 status code. To verify the deletion, let's refresh the table data in SQL Management Studio. Indeed, the product with ID 1 has been successfully deleted, confirming the correct functionality of our delete method. This validates that all our API methods are functioning correctly. Moving forward, let's create a library where we can implement the API calls. This approach offers the advantage of being able to use the library in any application where API consumption is necessary. Let's start by organizing the project structure. I'll add a solution folder named API and place our existing API project inside it. In the same folder, I'll create a new project, opting for the class library project template. I'll name it demo.api client. For compatibility across various .NET applications, including Xamarin, Maui, Blazor, MVC, console applications, etc., I am selecting .NET Standard 2.1. Now, let's proceed to create the project. I'll begin by deleting the auto-generated class as it is not needed. Now, within the project, I'll create a new class named Demo API Client Service and make it public. Inside this class, I'll declare a read-only HTTP client object which will be utilized for making API calls. In the class constructor, I'll instantiate the HTTP client object. Next, I'll create a folder named Models within this project. Inside the Models folder, I'll create a model class named API Client Options. This class will have a single property, API base address. We'll pass the API base address from the consumer application during dependency injection, similar to how we did it for the DB contacts connection string. I'll demonstrate shortly how we'll use this. For now, we can provide the API client options as a parameter in the constructor. Let's proceed to assign the base address of the HTTP client object within the constructor itself. This ensures that the base address is set upon the instantiation of the demo API client service class. I'll add another folder inside the models folder to accommodate the model classes required for the API calls. Inside this new folder, I'll create a model class named product, and I'll include all the necessary properties. Now, let's proceed to create the methods for each API calls. Initially, I'll create a method named getProducts, which will fetch all products. We'll utilize the HTTP client object for consuming the API method. To simplify JSON serialization and deserialization, let's install the system.net.http.json library from NuGet packages. This is the library we need. Let me install it. Once installed, we can use the getFromJSON async method, which is the part of this library. We specify the deserialization data type, in this case a list of products, and pass the API method as a parameter. Next, let's create the method named getById. Similar to the previous method, we can use the getFromJSON async method, but in this case, the API response will be a single product. We need to mention the API method and also pass the ID along with the URL. Let's continue by creating a method named saveProduct. Since it's a HTTP post method, we'll use the postJSON async method. We can pass the URL and the product object as parameters. In our next method, we address the process of updating a product. For this task, we use the putJSON async method, passing the necessary parameters to facilitate a seamless update. Our final method in this series pertains to the deletion of a product. To achieve this, we utilize the deleteAsync method. In addition to the URL, it's essential to pass the unique ID of the product that needs to be removed. With this, we conclude the implementation of all the essential API methods. Let's proceed by creating a folder named IOC. Within this folder, I'll create an extension class named Service Collection Extension. I'll make this a public static class and add a public static method named addDemoAPIClientService. This method will be utilized during dependency injection. The first parameter is iServiceCollection, for which we need to install Microsoft.extensions.dependencyinjection.abstractions. I'll take care of that. The next parameter is an action of API client options. If this sounds a bit confusing, don't worry, it will become clearer when we perform the dependency injection. We'll utilize the configure method to pass the options as a parameter. To use the configure method, we need to install one more library. I'll install the Microsoft.extensions.options library from NuGet packages. Finally, we can add our demo API client service as a singleton service. We'll soon use this method to add the dependency in the API consumer project. Moving forward, let's initiate the development of a Blazor project, which will make use of the API client library. To organize our project structure, I'm creating a solution folder named Presentation. Within this folder, we'll create a new Blazor project. We are opting for Blazor Server App Project template. Let's proceed by providing the project name and location, and then proceed with the creation of the project. In the Solution Explorer, you can now observe the project files. I'll open the program.cs class and guide you on how to add the demo API client service dependency. To begin, we must add the project reference. This step establishes a connection between the Blazor project and the API client library. I'll initiate the simultaneous running of both the API and Blazor projects. Both applications are now running, and you can observe that the API application is actively listening on port 5015. For better organization, we can place the API base address in the app settings.json file. Let's proceed to add the dependency. We can conventionally call the extension method we created earlier. Additionally, we need to assign the API base address value to the options. To achieve this, we read the base address from the app settings.json file, streamlining the configuration process. Let's continue by opening the index.razor component. Here, we'll implement the product CRUD functionalities on the index page, providing a comprehensive overview of how to interact with the API through our Blazor project. To initiate the process, let's obtain the injected dependency demo API client service. In the code section, we can proceed with the implementation of the methods. Initially, I am declaring a collection of products that will be presented within a table. Subsequently, we'll create a method dedicated to populating this collection, seamlessly utilizing the getProducts method from our API client library. Moving on to the next method, let's implement the functionality for adding a new product. We'll declare another object that we can use while adding the product. Utilizing the saveProduct method of our API client, we can seamlessly add the product. After saving the product, we'll load the products again to refresh the table. Additionally, we'll assign a new object to the addProduct model to clear the existing data, ensuring a clean state for the next addition. The subsequent method is designed for editing a product. This method accepts the edited product object as a parameter. We can conveniently call the updateProduct method of our API client to execute the update. Once the product is updated, we refresh the table by reloading the products, ensuring the display reflects the most recent changes. Our final method is dedicated to deleting a product. This method makes use of the deleteProduct method from our API client library to seamlessly remove the specified product. Subsequently, we reload the products to refresh the list, ensuring that the latest changes, including the deletion, are accurately reflected in the display. Now, let's focus on the design aspect. I won't delve deeper into the Blazor design here. If you wish to learn more, I recommend checking out the Blazor tutorial playlist where you can find the comprehensive guidance. The playlist link can be found in the video description. For each product in the list, I'll display the details using a separate Razor component named Product Row Item Component. I'll focus on providing the design and code sections here. Let's proceed to run the application and observe its functionality. Here, you can view the products that are already saved in our database. I'll attempt to add a new product, and as you can see, the addition process is functioning correctly. Now, let's try editing a product by modifying the values. The product has been updated successfully. Next, I'll attempt to delete a product, and you can observe that this operation is also working seamlessly. For a comprehensive overview, let's also inspect the data in SQL Management Studio. As you can see, the table data aligns with our expectations, confirming the successful integration of the Blazor project with the API. In conclusion, we have embarked on an incredible journey of building a robust .NET Core Web API and a dynamic Blazor application. This is just a glimpse into the vast possibilities of API development and integration that can unlock for your future projects. If you found this video helpful, don't forget to like, share, and subscribe for more exciting tutorials. Thank you.